is to be solving these inequalities using division and multiplication. Okay. You guys remember yesterday we did this kind of thing here where we put these two dots on here, and then we added something to both those dots, both those values, and then seeing if the relationship between the x's was the same as the relationship between the dots. Yeah. I want to do the same thing. I want to do the same thing here with.
Wait, we did that yesterday?
Yep. All right, so here it says let A, B, and C end up being real numbers. It just means that they can be anything that you want them to be. But now it says C is going to be greater than 0. So that becomes pretty important to us, that we want to be multiplying here by a positive number. Okay, C has to be positive here. The idea is if 3, would you guys agree that 3 is greater than -2? Yeah. Okay, so let's look at 3 here on that, and then let's put -2 right there. Okay, what do I get if I take 3 and multiply it by 2? I get 6. What do I get if I take -2 and multiply it by 2? -4. If I keep that inequality sign the same direction, okay, think about what just happened. This blue point was 3. It now just went there to 6, right? And then this -2 went to -4. If I look at the relationship between the dots, the values that we started with, is the orange one to the left of the blue one. Yeah, which is what we said, -2 is less than 3, right? -2 is less than 3. Or 3 is to the right of the orange one, so 3 is greater than -2. When I double both sides, is the orange one still less than the blue one? Is the orange X less than the blue X? Or vice versa, the blue X is greater than the orange X, right? Okay, so what does that tell me? That tells me that the order of comparison doesn't change at all when I multiply both sides of an inequality by a positive number. Does that make sense? The orange is still less than the blue. If I multiply both sides by 3, the orange will still be less than the blue. Does that make sense? Yeah. Okay. In the same, that this says, this is just the idea that if I have a less than statement, so right that says -2 is less than 3, then when I multiply both sides by 2, it'd be -4 is less than 6, which is the same thing this is saying, right? It's just basically saying we can still read these left to right or right to left, getting the same results. Okay. Questions on that? Does that make sense? So why do we need to know that? Well, here's the idea. If I have 1/2 x is greater than 4, how do I solve this? If this was an equation, how would I solve for x? Okay, divide by 1/2, which is exactly the same thing as multiplying by what? Okay, so reciprocal would be just 2, right? So if I multiply this side by 2, those will cancel. It means 1x. Multiply this side by 2 gives me 8. So if 1/2 x is greater than 4, that means x is actually greater than 8. All I had to do is multiply both sides by some positive number 2. That's exactly the same way I solved the equation if it was 1/2 x equals 4, right? Okay. Now we're going to throw a little twist in. This is the twist that occurs with all inequalities, but it only occurs when you are having a c value. We're going to multiply by c, and c ends up being, if it's less than 0, it's what kind of number? Negative. Okay? So here they're saying if a is greater than b. So give me a number. Let's use these numbers down here. So 2 is greater than -1. Would you guys agree that 2 is greater than -1? Okay. Take 2 and multiply it by -3. Take -1 and multiply it by -3. So I want to take this inequality right here and multiply both sides by -3. If I leave my inequality the same direction, I'm just choosing a c value. Somebody said, why are we multiplying by -3? I'm just choosing a c value that matches up to that rule right there. C is negative.
in the direction, but I didn't read that.
Okay. So then we get negative 6. This inequality was what we started with, right there, right? Right there. And this result would be, what's negative 1 times negative 3? 3. That's not true, right? That's wrong. That's the opposite of what it should be, correct? Okay. So here's what the argument and the rule is saying. If I multiply this negative or 2 by negative 3, it goes to, it takes this red dot and makes it over here that one. And it's going to take this blue one and put it over here at 3. So do you see how it takes, if I look at just the dots, blue is to the left of red, right? When I look at the x's after I've multiplied both sides by a negative, now the orange is left of blue. It flipped the order of them, okay? So we have to be aware of that. We have to pay attention to that. And the idea is if you multiply by a negative number, look at what they're doing here. If it was A was greater than B, if A was greater than B, multiplied by a negative number, this product AC, see how they flip the sign, is less than BC. So here, when we did this multiplication, 2 times negative 3, and then negative 1 times negative 3, when we're done, we should actually take that sign right there, and it should be flipped. So we really want to do, what was it? Greater than so wants to go that direction. And now, is that true?
Yeah.
Yes. Okay. So that kind of demonstration there is telling us that every time you multiply by a negative number in an inequality, when you multiply by a negative number, you need to flip the direction of the inequality symbol. Okay? You turn it on a 180 and make it go the opposite direction that it started at. Is that okay?
Yeah.
Okay. So what happens if I multiplied by negative 2? Let's say this.
Name one.
Let's see here.
Just do like a random number.
If I divided by negative 2, what's that the same as multiplying by?
By 1 over 2.
1 over 2. Negative 1 over 2, right?
Yeah.
So dividing by negative 2 is the same thing as multiplying by negative 1/2, right?
Yeah.
At any time that you ever say, I'm going to divide by this amount, I can reverse that and say, well, you multiply then by that amount's reciprocal. Does that make sense?
Yeah.
So that means whenever we divide, we can actually do it through multiplication instead. Or whenever we multiply, we could really think about it as division if we need to. Does that make sense?
Yeah.
Okay. It's like adding. If I'm going to subtract, can I actually change that into adding the opposite?
Yeah.
Yeah. Okay. The reason I say that is because this rule here talks about just multiplying A and C and B and C, right?
Yeah.
But it just says C is less than 0. Well, there are numbers that are less than 0 that are not whole numbers. There are numbers that are less than 0, like negative 1/2. If I multiply by negative 1/2, that's the same as dividing by negative 2. Okay? So the argument is whenever you multiply or divide by a negative number in inequality, you have to flip the inequality symbol. Okay? So both operations, multiplication or division, you flip the inequality. So, that being said, we got some examples here. But before we get these examples, I just want you to understand that whenever we introduce properties with inequalities, usually they just introduce them with a less than and greater than, and then they'll add kind of a phrase that says, everything we just did is also true when equality is involved. Okay? That's what we've got here. So, this first example, what are you going to do to solve for x? Do what?
Multiply by 3.
Multiply both sides by 3. Okay? So multiply by 3. Those are going to cancel, right? Gives me 3x over 3, which is just x. Come over here and multiply by 3. Gives me negative 6, right? Now, did I multiply by a negative or a positive? Positive. So that doesn't change the sign, right? That symbol needs to say pointing towards the left. So now what kind of dot do I use at negative 6? Open dot at negative 6. And now which way do I graph? Left or right? All right. Is that good?
Yeah. Wait, so pot.
Is that the same way that you have solved this equation?
Yeah. Is that an 8?
It's a 3. Would you multiply both sides by 3?
Yeah.
You got x equals negative 6, right?
Yeah.
Oh, it's the same thing here. It's just we interchange that equal sign with an inequality. What about this next one? What?
Okay, so if you multiply by the positive, it's the same thing. But if you multiply by negative, it changes. It flips.
Yep. Yep. All right. What about this one? What do I need to multiply both sides by? Negative 2. Excuse you. So your Y or W, and I get negative 4 over here, right? But what did I multiply by? A negative. So that symbol needs to change to that symbol, right? So it would be closed at negative 4, and we'll go left. Now think about what would happen. I think it's important for us to recognize this. Let's say that I didn't. Let's say I have W over negative 2 is greater than or equal to 2. I multiply both sides by negative 2, but I don't change the sign. If I don't change that symbol, I would graph all of that stuff in red, right?
Yeah.
Would you agree that that is 100% the opposite answers? That's everything that doesn't really work for the inequality, right? So that's why we have to flip it, or we're going to get all the solutions that are really not going to work. Okay? So that's just something to keep in mind, and why we have to flip those symbols.
This a brief thing work? I just saw it and I didn't know.
What?
Thing right here work.
I don't know. No, don't. No, you guys smell too bad.
Alright, bro. Wait,
No, there's no batteries in it. All right, so what do I need to do here to solve? Divide by 2. Okay, good. So divide by 2, so it's going to be x less than 7. Open dot, close dot. Open. So open dot at 7, shade left. Okay, so now what do I do on this last one? Divide by negative 3. Okay, good. So what's 21 divided by negative 3? Negative 7. And now it was a less than, so I divide by negative, so it turns into greater than or equal to. Open or closed? Closed. Which way do I graph? Graph to the right. Okay. Remember what graphing to the right means here. It means that no matter what number I pick over there on the right of negative 7, when I plug it into that inequality, it will give me a true statement. So I plug in 0. Negative 3 times 0 is what? 0. Is 0 less than or equal to 21? Yeah. Okay. So it satisfies, so it works. Yes.
If it's a negative, it has greater than or equal to that. And then if it's a positive, no, if it's a negative, you flip this thing.
No, yeah. So the inequality sign is going to be, in the original inequality, it's going to be provided for you, right? So it might be pointing to the left, it might be pointing to the right, whatever. Okay? We don't really care at the onset which way it's pointing, right? But if I divide by a positive number or multiply by a positive number, it stays the same way it was in the original problem. Yes, if I multiply by negative or divide by negative, then it's going to switch directions. All right, so this last one here, and you saw a couple of these in yesterday's homework. These are the types of questions, guys, that the end of course exam is going to provide you. They're not going to give you one of those that we just did and say, can you solve for X? Because the idea, think about what mathematics is for. What do you think mathematics is for? To learn? For what? But think about it. So you go through an English class, so you can learn to read, so you can learn to write, so that when you get beyond high school and you have to fill out things for a job, you have to fill out applications, you have to write letters to your employer, you have to write emails, that you are a professional in doing that, right? And that you're capable of doing that, okay? Mathematics, the reason we learn mathematics is so that Not so that when I'm out of high school, that when I'm walking down the street, somebody comes up to me and says, hey, negative 3x less than 21, what is it? Nobody's going to do that, right? You're not going to see that any time beyond high school. But what you are going to do beyond high school is say, okay, I've got a bill that's going to be $300, and I make this much money per hour. What's the bare minimum hours I need to work so I can pay off that bill? Does that make sense? That's where you're going to use this type of math. So then, of course, the examiner is going to ask questions like that because they're trying to judge whether you have the capacity to do math beyond a classroom setting. Okay? So when we see questions like this, okay, a couple phrases that are important to us, keywords like at most and at least. Okay? What's at least mean?
At least
that number or less.
less. Why do you look like that?
At least that number.
When I say at least, that's the bare minimum number I need to get to. Okay? So they're setting a low value for you. Okay? So when they say at most, they're setting a high value. They're setting your maximum. You can't go above that, right? Okay? So here they're saying at least. So this would be, what is the bare minimum number of hours I need to work to make $300? If I work over that, I'll make more than $300, which is fine. Okay? Does that make sense, everybody? Okay, so if I'm using this in my real life and I get the idea of at least or at most mixed up, and I reverse it and I say, well, I got to work, I think the answer here is like 41 hours, okay? And I mess those up, I might not work enough hours to be able to pay that bill off, okay? So here's the idea. I want to get to 300, right? That's my goal. Get to $300. I make $7.25 an hour. Okay, so if I work 1 hour, how much do I make?
$1.
Okay, $7.25. Is that, so when I say at least, okay, are those equal? Let's do that first. Are they equal? No. Okay, so then I got to work 2 hours. Are they equal now? No, so then I got to work 3 hours, right? Are they equal now? No. So the idea is that I've got to keep working more and more hours, right? Well, I don't know how many hours I need to work yet, right? So what do I let that 1 or that 2 or that 3 actually be in my problem? I let it be my x. That's the thing we're trying to figure out, the number of hours that we're looking for here, okay? So if I were to divide that out, that would tell me exactly how many hours I need to work, right? Well, I want to know at least how many hours. So this is my amount of money that I make, right, per hour. I want that to be either equal to $300 or greater than $300. Does that make sense? Okay, so I'm going to go, so when I see the phrase at least here, it means my kind of variable side of this inequality has to be greater than or equal to 300. Because when it's greater than or equal, it met the requirement of being at least 300. Does that make sense? Okay. So then I divide that out. Divide by 7.25, right?
Mm-hmm.
Does that give you a nasty kind of number? 41.379. So it's going to go like that. 0.38. So 40. I got to work. Is that right? Did I write that down the way you said it? Okay. So 41.38 hours. Okay. I got to work a little bit more than the average work week, right? Does that make sense? Or go find a better job. So I work less hours, right? Okay. But that's what they're going to ask you on the end of course exam. Can you set up the inequality from a word description, from some context, and then go through and solve it? Okay. So you see a couple of those in your homework and see those play over throughout the rest of this chapter as well. All right. You've got about 15 minutes here, guys. I've got the assignments open. I'd like you to work on it. Something I've noticed, not